Ladies and gentlemen, today what we're going to talk about is the normal distribution. We are going to draw conclusions about a population that is normally distributed. And one of the first things we're going to learn about the normal distribution is something called the 68, 95, 99.7 rule. So our goal today is to be able to understand that and how to apply it in context of a problem. So the first thing that you need to know, and what I want you to do is I want you to draw down this normal distribution curve. Okay, some people call it the bell curve. Okay. You'll notice it is symmetric, unimodal, okay? And what we do to describe this normal distribution is down the center right here. This is always the mean of the distribution, okay? And how we call the mean, I call it mu, okay? MU is how you say it, mu. It is a Greek letter. And when we're drawing these conclusions, we're drawing conclusions about a population. And so instead of using X bar for the mean, we use this Greek symbol, mu. Okay, so we're going to write that right here. And then in all normal distributions, what we do is we measure 3 standard deviations above the mean and 3 standard deviations below the mean. So what I'm going to do is I'm going to take and I'm going to find 1, 2, and 3. Okay, so this is 1 standard deviation above the mean right here. This is 2 standard deviations above the mean, and this is 3 standard deviations above the mean. And again, why am I not using the SX? Why am I using this, what we call sigma here? Because we're describing a population right now, and these will be given to you. When you calculate something, when you get a list of data in your calculator and you find an X bar and an SX, those are statistics. Those are describing a sample. These right here, these are called parameters. The mu here, the standard deviation, because they're describing the population. And again, it will be given to you. Like I said, we have this normal distribution, which is this symmetric curve right here. We have the mean in the center. We take 1 standard deviation, 2, 3 standard deviations above the mean. And then we also go below the mean. Now, how do you know where to put it? It's kind of arbitrary. For those of you who have taken calculus, we technically need to find the point of inflection where it changes from concave up to concave down or concave down to concave up. But for regular statistics, we can just pick somewhat of an arbitrary point, okay? Oops, I'm gonna use my nice marker or my nice arrow here. So again, 1 standard deviation below the mean, 2 standard deviations below the mean, and approximately 3 standard deviations below the mean, okay? And so let's write that down. So minus 1 standard deviation below the mean, minus 2 standard deviations below the mean, and minus 3 standard deviations below the mean. And now what we're doing is we're able to draw conclusions about this population. One thing that we know is that 68% of the population of a normal distribution will fall within 1 standard deviation of the mean. So again, please write this down. We also know that 95% of people or observations will fall within 2 standard deviations of the mean. And if it looks familiar from Algebra 2, you did learn it in Algebra 2. And then finally, we have 3 standard deviations. 99.7% of people will fall within 3 standard deviations of the mean. Again, our goal as statisticians is we're drawing conclusions about a population. And then after we draw those conclusions, later on, we're going to make decisions based off that conclusion, okay? Well, we can figure out some more things too, okay? Within the first standard deviation, so 1 standard deviation above the mean to the mean, 34% of people will fall. Okay, so 34% of people fall within this interval. And 34% of people fall within this interval. 34% of people will be 1 standard deviation below the mean to the mean, somewhere in this interval. People who score or have a standard deviation or a z-score, okay, from the 1 standard deviation above to the mean to the 2nd standard deviation above the mean, that's 13.5% of people or observations will be within these 2 standard deviations here, 13.5. And then 3 standard deviations. So between the 2nd and the 3rd standard deviation, there will be 2.35% of the population. Now, if you're like, what is she doing right now? just get it down and we'll apply it in context in the next slide, okay? But we want to get this whole thing down so we can use it in context for our next problems. Furthermore, is there anyone who that will be above 3 standard deviations above the mean, okay? Yes, there is. And that's 0.15% of people or objects or whatever that you're describing that normal distribution by. Now this is symmetric, so the same goes over here, 13.5%. (2.35%) and 0.15%. And again, if you've taken calculus, how these numbers were found is it's area under the curve, okay? We're not doing that, but just in case you've taken calculus, just to give you a little side note there. All right, so let's take what we've drawn here and let's actually apply it to context, okay? Let's apply it to context. So I'm gonna take a picture right now. Well, no, I'm gonna redraw it actually, okay? So I have an example here. The ACT is a nationally standardized test that follows a normal distribution with a mean of 20 and a standard deviation of 4.5. Now I will have the blank notes printed out for you so you can follow along there, or you can pause it and write that down if you'd like. Number 1, it says, using the values, draw the normal curve with the values for the mean and the standard deviation. So I'm going to do that now. I'm going to draw a nice normal curve. And again, I'm using my mouse. So if it gets a little shaky, I apologize. In the center will always go the mean. So our mean they give us is 20. So I'm going to put mu. And then we measure 3 standard deviations above the mean and 3 standard deviations below the mean. Our standard deviation is 4.5. So we're going to add 4.5 every time when we're going above the mean. So 20 plus 4.5, that gives us 24.5. 24.5 plus 4.5, that's going to give us 29. And 29 plus 4.5, that's going to give us 33.5. Okay, now we're going below the mean. So we're going to take 20, guys, and we're going to subtract 4.5 because these are our standard deviations below the mean. When I do that, I get 15.5. Okay, and then again, so 15.5 minus 4.5, well, that gives us 11. And then I'm going to subtract 4.5 one more time, and that gives us 6.5. What I'm going to do is I'm going to quickly move all of this down so I can write a little bit more. What do I remember? I remember that 68% will fall within the first standard deviation of the mean, okay? Within standard deviation. Oh dear, I'm running low. 1 second. I gotta pause. 95% will fall within 2 standard deviations of the mean. So 95% of people, based on this data, will get an ACT score between an 11 and a 29. 68% of people will get an ACT score between a 15.5 and a 24.5. And 99.7% of people will get a Z-score between a 6.5 and a 33.5. Will there be people that give above a 33.5 and below a 6.5? Yes, but that's very rare. Remember, this little area there is 0.15%. 0.15% of people will be above a 33.5, or 0.15% of people will be below a 16.5. Again, what am I doing is I'm just taking these values that we just talked about, okay, and applying them in context. What else do we know? We know that 34% of people will get an ACT score between a 20 and a 24.5, and the same as between a 15.5 and a 20, 34% of people will get that. 13.5% of people will get an ACT score between a 24.5 and a 29. And the same as over here, 13.5% of people will get an ACT score between 11 and a 15.5. And then finally, this area right here, 2.35%. 2.35% of people will get a Z-score between, or I'm sorry, an ACT score between a 29 and a 33.5, as well as over here. 2.35% of people will get an ACT score between a 6.5 and 11. Okay, so number one, that will be the first expectation, that you know how to use this mean and the standard deviation to draw the normal curve and mark the values out. Next, let's answer the question. Approximately the top 16% of all ACT scores are at least what score? Well, we want the top ACT scores. We know that the average is right here at 20. We want the top 16% of scores. So I'm going to do a little bit of shading for you. If I look here, this is the top 0.15% of scores, a 33.5 and above. Someone who got at least a 33.5 is in the top 0.15% of all scores. What about if we got at least a 29? That would be everything from here all the way over here again, okay? If I got at least a 29, that's a top score, right? That's above the mean. If I got at least a 29 on the ACT, I have 2.35% of people get between a 29 and a 33.5, and 0.15% of people get between a 33.5 and above. So that's going to be the top, well, 2.35 plus 0.15, that's going to be the top 2.5% of people will get at least a 29. So you can see this yellow area plus this little yellow area is at least 29. Let's keep going. What if I got 24.5? Well, 13.5% of people will get between a 24.5 and a 29. But to get at least a 24.5 means I got anywhere from 24.5 going this way. Okay? At least a 24.5 could be a 29, a 33.5, or even a 36. That's at least a 24.5. So what I'm going to do is I'm going to add these values up. 13.5 plus 2.35 plus 0.15, and that gives me 16. 16%. Right here, this yellow area is the top 16% of all ACT scores. Again, how did I do that? I knew I'm in the top, so I started over all the way to the right and went backwards and added up these percents until I got 16%. What score do I need to be in this yellow region? I need at least a 24.5. And that's my answer right there. Number 3, the middle 68% of ACT scores are between blank and blank. Well, I know, ladies and gentlemen, that the middle 68% are within that first standard deviation, right in this area right here, between all this area, between 15.5 and 24.5. 68% of people get between a 15.5 and a 24.5, right here. So again, our goal is we're just taking this normal distribution, the 68, 95, 99.7 rule, and applying it in context to a problem. And we get 24.5. Okay, the next one, only 2.5% of ACT scores are higher than what score? 2.5. Again, higher than. We want a really good score. We want only 2.5% or higher than this. If I look down here, well, higher than 11, that's a big percentage, right? Higher than 6.5, that's a huge percentage. Higher than 15.5, again, if I'd add up all these scores, again, a big percentage. Higher than 20, add up all these percentages, big percentage. Higher than 24.5, we already figured out, that's 16.5. But higher than the score of 29, well, that's 2.35 plus 0.15. Together, that gives me 2.5%. Okay, so What percent or only 2.5% of ACT scores are higher than this number? We're going to say 29. And last question, what percent of scores are between 15.1 and 29? Let's see. Okay, we're going to call this in here, and I'm going to change this to 15.5. Okay, 15.5. So what percent of scores are between 15.5 and 29? I can't do a 15.1, guys, because that's not on the graph, and we haven't learned how to do that yet. But I can do a 15.5. So between a 15.5, so that's right here, and a 29, that's right here. So that's all, I'll do it in a highlighted so it looks a little better. That's all this area here. Between a 15.5 to a 29, okay? It's all that highlighted area there. So what am I gonna do? I'm gonna add up 34 plus 34 plus 13.5, okay? 34 plus 34 plus 13.5. And what do I get? I get 81.5%. All right, ladies and gentlemen, what you've learned from this video, okay, we should learn how to mark out the 68, 95, 99.7 rule for a normal distribution and apply it to a problem. Thanks so much, guys. We'll see you back in class in a second.